Example of the variance. What's the variance of the number of empty bowls? Bowls. Okay. Well, let's see. So I need to think about what I'm doing here. What was the mean for the number of empty bowls? It was about 0.59259. So this is going to be, I'm going to follow the formula that's up here. Right? I'm going to follow that formula, and k could be 0 minus 0.59259. I'm rounding there. I hope that's okay. I'm going to square that, right? And then now times the chance that I had 0 empty bowls. What was the chance of no empty bowls? It's 36. 36 out of 81, right? And then plus 1 minus 0.59259, quantity squared, times 42 out of 81. And then plus 2 minus 0.59259, quantity squared, times 3 out of 81. Okay? And you can figure out what that is. All right? It's a teeny tiny little theorem, I guess. Your book calls it a theorem. It's kind of silly, but if I don't know, let x be a random variable, discrete. Of course, we're only talking about the discrete case right now. Let x be a discrete random variable, and c be a constant. Then the expected value of c is just c. Okay, that should seem sort of trivial, right? The expected value of a constant is a constant. It's not moving around. By the way, what should the variance of a constant be? Is it varying? No, it's constant. The variance of a constant is 0. We can show that later on if we remember. But all right, so here's the proof. So suppose g is a constant function. Okay, g of whatever you stick in there. G maps the reals to c. Okay. Then can we write this? The expected value of c is the expected value of g that g function there. Maybe I could say, like this, g of x. It's the expected value of g of x. And then by that theorem, we know how to write this, right? It's the sum of g of x times the probability that, oops, need a k there, dummy variable, x equals k. Don't make the same mistakes I did. Okay, and this is over all the values of k, I guess. Okay. All right. Now, but this thing is a constant, right? So it's c times the probability that x equals k. Hey, I know that I can factor that c out. This is c times the sum. And then finally, I think we have a probability axiom that says that the sum of all the probabilities of these disjoint events has to be 1. And so it's c. And there we go. Good job, guys, gals.